The recording has started. But yeah, um, but yeah. So this is our August show and tell. I think we have two people signing up. We have Carson and Tanvi. Oh, we will have Jack as well. Nice.
Mhm. I don't.
So I guess Carson, do you want to take it away since I saw your name first?
Sure. So yeah, I've just been working a little bit over the summer on my haptics project. I call it Touchstone. I think I did one presentation before about it, but I've mainly been working on the software because right now the hardware is a bit janky, and I'm working on upgrading it to use some brushless motors. Should be a lot better at providing consistent haptic feedback than the cheap servos I was using before. Um, yeah, but that requires a lot of electronics design that I'm working on right now. Once I get that done, hopefully it'll work better. What I wanted to show you guys was when I'm working on how to get the software layer to interface so that you can simulate things virtually and translate the forces into the physical device. So my Unity programming, it's a bit limited, but I think I've got it pretty good now. Let me just share my screen here. Uh, all right, so let's see. So what I've got here is essentially like a digital twin of the hardware. Um, and then that kind of purple thing in the middle is the node that you actually put your finger into. And in the future, hopefully there'll be um hopefully there'll be more nodes. Can everybody see my screen actually?
Yeah.
Okay, yeah. Hopefully there'll be more nodes in the future, like full hands. So there'll be 5 nodes on one hand, one for each fingertip, maybe one on the palm as well, to communicate different aspects of forces. And the idea is all these nodes are omnidirectional. So you could have force in any direction. You communicate that to the hardware. So let me just go ahead and run it here. Now, um, yeah, I essentially have this layer that will so it's connecting to a server a server. The server is a C++ program that's running on my machine. It's not running right now, but um, that layer runs all of the like sensor fusion and processing, and also communicates with the microcontroller. And then it connects it with a local socket to the Unity application. I actually have a diagram I was going to show here. Let me find that somewhere around here. Yeah. So the firmware layer is on the microcontroller. It does basically I/O, and that communicates with serial over to the interface layer. The interface layer takes in the sensor data and then sends out actuator commands. And then the application layer is what's running in Unity or another game engine. I kind of designed this way so it can be flexible. Like I can write an application layer in different softwares. And then interface will send it localization data of like where everything is. And then the application layer will send out what kind of haptic feedback it wants to create. So let me go back to Unity here. Yeah, so right now, let's see. Yeah, I can turn on sending feedback to the hardware here. But the main thing is I need to turn on debug mode so I can actually move the thing around. So usually the hardware would be sending commands to the to determine the position of this. But I'm just moving around with keyboard commands right now because the hardware is not really working that well. And also I'm on vacation right now, so I don't have access to it. But there's two main components. You can see kind of the red thing. That's called the mirror object. And so what that one does is it just copies the location of the hardware. So wherever the hardware is, it just copies that. It does not interact with virtual objects. And then the blue one is kind of transparent and it's kind of like following it around. That's what I'm calling the shadow object. And so that one is kind of attached to the mirror object by a kind of virtual spring. And when I first did this, and I plugged in like a basic like second order differential equation for like a spring, I didn't realize how unstable it would be to run that in a game engine, because when it does like the frame by frame math, it often works out that if the spring is on, if it's on one side, then in the next frame, it'll be all the way on the other side, but it'll be further away. And then by the next frame, it'll be all the way on the other side and further away. And so it will just keep oscillating out of control. And so I found this thing you could do that's like a mathematical trick to approximate like a perfect spring that would return it to rest in exactly one frame. So there's no chance of it oscillating. And I could do that just by setting so the stiffness and damping instead become like fractions of a perfect spring. So right now I can turn the stiffness and damping to 1, and then it will just follow it around perfectly. And then if I turn the stiffness down, then it kind of lags behind it like so. And if I turn the damping down, it's gonna overshoot a bit probably. Let me see if that is what it does. It should do that. Yeah, it can kind of, yeah, you can kind of
So
see it vibrating back and forth.
what again
But
is like the pros and cons of like tuning these values, I guess?
I don't really know yet because I haven't done a lot of experimentation with it. But
It gives you
generally, there's a good
gives
bit
you
of noise
Mhm.
in like the position of the mirror object, and so the stiffness, decreasing the stiffness of the spring can kind of help balance out the noise a bit. But I don't know. I still need to experiment with a lot more. So the idea is you could use this to interact with both stationary and moving objects. So I have some things in green highlighted to show the feedbacks that's getting sent to the hardware. That like plane thing, the green plane things that are showing up, that is what I'm calling like collision anticipation. And so the
Mm.
point of that is, depending on what the hardware is doing, sometimes it's not going to be able to deliver force immediately. With the servos, it's just because I'm using a weird system. With the brushless motors, can technically deliver it immediately, but later I'm going to be using a system that involves like moving it around a bit more. The idea is by anticipating where it's going to collide with something, this gives it a bit of time to react and move stuff into place where it can deliver force when it actually hits it. So it's just based on like running the physics simulation a few frames ahead and determining where it thinks it's going to hit. Like as you can see, I can move around and it thinks it's going to hit these particular blocks. But the cool thing about it is that it's also it combines the effects of multiple things. So if I make these blocks move towards the object, you can see there's a plane that's kind of flat. And that's because it assumes that those blocks are coming at both sides. So it combines the momentum transfer from both assumed collisions, even though it didn't actually happen that way. So that way it can collide with multiple things at once and be able to anticipate that. But so the green arrow that appears is the actual force that's getting transmitted to the haptic system. And that force is essentially the spring force that's acting on the mirror object. It doesn't actually move the mirror object in the virtual environment, but it's the same force, like equal and opposite reaction, that's pulling the shadow object towards the mirror object. Uh, and if also if I go into the ground, it'll get a force. I still haven't fixed it oscillating around like that when you actually collide with objects. I assume I'll need to fix that by doing some kind of other damping or something. That's going to be problematic. But right now I can just interact with stuff, and yeah, hopefully once I get better hardware, I'll just be able to feed these commands to the hardware. Oh, and I can also turn on stuff like gravity. Like the shadow object has a mass per se. You can change the mass, and so I can make it weigh something. Um, I can also turn on inertia. So you could use this to simulate things like an idea is if you were simulating a sword that somebody was holding, then you need to simulate the inertial components involved in that sword. Like it's harder to move than just your hand. Well, it's harder to accelerate specifically. And so you can't really see it because it happens so fast. But when you well, because I'm just using the keyboard commands, but when you accelerate it, it kind of creates forces out to either side. They just kind of blink. They're just kind of blinking. But yeah, that's the inertia component. But yeah, that's pretty much what I've been working on. If anybody has any questions or ideas on how I could improve it, because as I said, I'm new to developing stuff in Unity, but we'll
This is
see.
insane.
Yeah, it's
I'm
very
really
cool.
impressed. I'm like seeing how much you have like in already in Unity with all of these parameters on the right, and like how you've set it up with all these like really well done like visualizations. And this whole digital twin thing, it's just like, especially since you said you haven't done much in Unity, like it's really impressive. It's super cool.
Yeah,
Thanks.
yeah, it's super cool. I'm very curious. What's the input and output from the application layer? Is the hardware there's like I think the blue dot, sorry, the red one is the actual position of the finger. Is that right? But like, can you actually
Yeah,
get the absolute like the world position of the finger from the hardware?
yes. So the hardware should be able to track the position of the finger like in real
Okay.
life um pretty accurately. Right now I'm just using like completely physical based tracking because I'm
Mm-hmm.
using like essentially strings that are attached to the thing in the middle. And
Yeah.
there's encoders on the motors that are driving the strings, and you use that to figure out the position. That's not very accurate. Um, it is faster than doing optical tracking. So I think I want to combine them for the final product and use
Sensor
the
fusion.
the hardware tracking for speed, and
Mm.
then
Like
the
IMU.
optical tracking for accuracy, hopefully.
So
Makes
it's kind
sense.
of like honestly how like VR controllers already like merge like IMUs for like speed, but then like camera based LEDs for like keeping it in the source of truth, you know.
Yeah, that's the idea. And I do have some I'm using the hardware as well. Um, the end goal is to be able to do it with all five fingers. That's going to require some more complicated math to get to work out. But the idea is I haven't have a IMU or accelerometer on each finger, and I also have two strings attached to each finger that can also give some approximation of where it is. And then I'll have an optical layer on top of that,
Gotcha.
hopefully.
Yeah. And in terms of the output of the application, because we see the force that you draw, like is the output instruction to each motor and how much to tighten the string.
Um, yeah, so the application layer will send commands like let me the server is the C++ application. That's kind of the middleman between the application layer and the firmware.
Mm-hmm.
And so the commands that the application layer can send is request node data. So that's basically like localization data, just a
Mm.
position and a quaternion. Um, it can send force feedback data, which is just a 3D force vector, and it can send collision feedback, which means anticipate that a collision is going to happen here with this normal vector in this amount of time and adjust yourself accordingly to be ready for that. Um, and this is just over TCP/IP. And then let's see where's this?
Dude, you are so
Or,
smart.
well, the middleman will send uh they'll send a servo power command essentially. The middleman will figure out what the powers on all the servos need to be to generate the correct forces.
Mm. Makes sense.
And then the
Yeah.
firmware will send back all of the sensor data. That's pretty much what happens.
Gotcha. Yeah. Thank you. Any other questions for Carson?
Um, I think you're, I mean, I don't, not that I, like, I think not that I think you need any help, but like, if you're interested, you should reach out to GTXR in the fall, because this is a really cool project, just like if we can be involved in any way.
Yeah, definitely going to do that. I'm looking for people to help me for sure, especially
Okay.
with the
Awesome.
software aspect.
We're probably going to do a more like weekly open office hours based thing this semester. like stuff like that.
Yeah, that would be cool because I wasn't involved that much with GTXR last semester, and I have to do that more this semester. So
Oh, good.
Cool. All right then. Thank you so much, Carson. And next up we have Jack.
Okay, could we actually pause the recording?
Sure.